Welcome to this video supplement involving finding the volume of water in a sewer pipe, which is really a right circular cylinder. As we see the problem on the screen, perhaps you want to hit pause and try it out before we work it through here together. So initially, if we look into the cylinder itself or into the sewer, this is what we would see. And if we're trying to figure out the area that's here shaded in order to determine the area of the base of the water before we find the volume, what we're going to do is draw in the two radii segments to the center of the circle. So we'll draw that and we'll draw that. In this problem, we're told that the diameter of the pipe is 14 feet, so the radius would be 7 feet. And in order to figure out the area of the triangle involved, we're going to need to draw in a right triangle here. We know that the water is 6 feet deep in the center of this sewer pipe. If the radius is 7, that means this additional piece is 1 because this is the center of our circle. 1 plus 6 is 7, and that's another radius segment. So now if we were to draw out this right triangle that we have, its hypotenuse is 7, one of its legs is 1. Let's call the other leg x, and we can set up the Pythagorean theorem, a squared plus b squared equals c squared, to have 1 squared plus x squared equals 7 squared. We're not solving this problem in exact form. So as we work it out, we get x squared is 48. Take the square root on both sides, and decimals are fine. So x is going to be 6.93 approximately, though we will keep the full decimal on our calculator. Now that we have that, we can also determine this angle right here in the triangle setup that we're investigating. To find that angle, we would simply do the inverse cosine of 1/7, because cosine involves the adjacent divided by the hypotenuse. So when we take the inverse cosine of 1/7, we will get that angle. And the inverse cosine of 1/7 is 81.79 approximately degrees. But the angle that we really care about when determining the area of our sector is this entire angle right here. So that entire angle is going to be double the 81.79, which will come out to be, keeping all of our decimals on our calculator, 163.57 degrees. So as we proceed, next up we're going to find the area of the total sector, which would be the 163.57 out of a full 360 times pi r squared. Keeping all of our decimals on the calculator, we get 69.95 for the area of the sector. Then we need to take away the area of the triangle. So when we find the area of the triangle, it's going to be some base times some height divided by 2. Notice this full base right here is double the x value. So it's going to be 2x times the height of the triangle is 1 divided by 2. Notice those 2's would cancel if we wanted to, so this area of the triangle is basically just x, which is 6.93. Therefore, the area that's shaded, or that's also equal to the area of our segment, remembering our terminology involving circles, is equal to the area of the sector, take away the area of the triangle, which in this case would be our 69.95 minus 6.93. And we're keeping all of our decimals on our calculator. So determining what that is, we get that this shaded area is 63.02. Now that's the shaded area. That's just this one perspective of the water. It travels through the entire pipe and then comes out on the other side in the same shape. So when we're figuring out the volume of that water in the sewer pipe, the volume just turns out to be the area of that base times the height. And the base area is simply that area of our segment multiplied by the height. So in this problem, that'll be 63.02. The height is the length of the sewer pipe. In this problem, it was 750 feet long. So we're just going to take that area of the segment and multiply it by. So in this problem, we're just going to take that area of the segment, multiply it by 750. And when we do that, we get 47262.59. 47262.59. Please put the correct label in there, and this would be cubic feet for the volume of water in that sewer pipe. So essentially, it's a problem that we've really looked at before, finding the area of a segment, and then once we find the area of the segment, we multiply by the distance between those bases, which is really the length of the sewer pipe.